Keep doing that.
Whoops.
Hello.
Hey, Anna.
Hey, how are you?
I'm doing good. How about you?
I'm surviving.
How'd your surgery go?
It was okay. It sucked, but it is
What?
what
What'd you do for your surgery again?
it was. Well, like official term was like a pilonidal cysterectomy or whatever, and so I had the cyst, and they pretty much just removed all the skin and stuff around that area.
Gotcha.
Yeah.
Sounds rough. Is that kind of why you were sick on Tuesday?
Yeah. I've been kind of feeling gross since, but I mean, I have to just get over it and keep going.
Yeah, it sucks to do that right in the middle of the semester.
Yeah. I didn't really have a choice though with it, so but it's okay.
Gotcha. Well, let's get started. I'm going to apologize right off the bat because 4, I have no idea what it's talking about.
I think I got one coordinate point.
Well, so I don't get how there's multiple coordinate points.
Yeah, I don't either.
Like, I read through the whole book, and it just does not make sense to have multiple coordinate points.
Yeah.
But the coordinates I did get were, oh wait, it doesn't even make sense. Pair and forward coordinates. Okay, so I got that it was like 34 degrees or 39.
For that?
Let's see.
I didn't do it right.
Oh wait,
I thought you looked at the unit circle.
I'm confused. Yeah, let's just start at 1. Let's start at
Okay.
1.
And then I'll tell you what I thought
I'm
you didn't get one at all.
I'm confident on 1.
I'm glad because I looked at one and I read it and I was like, did all the homework. That was like, there was nothing.
No, trust me once. Here, I'll draw a picture. It's actually one of the easier ones for me. Okay, let's go to desktop, screen share. Okay, presenting to everyone. Let's do. Okay. So we'll draw a picture. So this is kind of like a vectors question.
Mm-hmm. Oh.
So if I'm going and I'm swimming west, if I'm going in this direction, right? And I'm going, what does it say, 3 miles per hour? So that's a vector going that direction. And then while I'm swimming, a vector goes and pushes, the water is moving north at 6.2 miles per hour. So the guy's still trying to swim. Oops, let's go a little higher. the guy's still trying to swim west at 3 miles per hour, and the water is taking him north.
Okay.
So basically, what's going to happen is the water, if he's only swimming west 3 miles per hour, but the water is traveling at 6.2 miles per hour, he's basically going to be going in that direction, right?
Yeah.
So it's just a regular vector question where you get 3 squared and 6.2, 3 squared and 6.2 squared, and add them together, and then find the square root of those. So go ahead and do that and tell me what you get.
Oh gosh. Hold on, sorry.
No worries.
So then I have to do what after I square and add them?
So if you square, add them, and then find the square root, that's going to be the magnitude or the speed of how fast this person is going.
Right. Okay. So I don't know if that's right. Did you go like 6.88?
So yep, I got 6.89 if you round up.
Yeah.
Nearest hundredth. Because doesn't that make sense? If you're swimming in one direction and the water is traveling in a certain direction, you're going to go faster towards that direction, right?
Yeah.
And to find the angle of what you're going, you do, it's just any other magnitude question. You get the arc tangent, and then you do y over x. So it's going up 6.2 divided by 6.2 divided by 3, and that equals 64.18. And so you take 180 minus 64.18 and it equals 115.82 degrees.
Okay. Did we do anything with the arc tangent or whatever that like name is in the homework?
Yes.
Was it like the last two? Because I don't think I did the last two.
No. Let me show you. Wait, wrong way. Am I still screen sharing?
Yeah. Oh, was this on the second one? Okay.
Oh, it was the other homework. Sorry.
Oh, that was weird at first. For a second.
Let's see. It's going to be in one of these. Let's see. Yeah. So, let's see. So here's an example. So in question 11 of 20 in the first section of the homework this week.
Yeah.
It just has 1/3. So if you do, where's my nifty calculator? There it is. So if I do 3 divided by 1 arctangent, I get 71.6.
Okay. I thought. I don't remember what I did for that one. I thought for some reason it was like the inverse of something else.
Sorry, what?
I thought it was the inverse of something else that you used.
Maybe check in the book. Like I feel like there's different things to use, but when you're doing like magnitude and direction of the angle or the vector, you definitely do the arctangent.
Okay.
And then you could kind of picture it too. Like, let's see, let's go back to this. If move this down. Let's see. So if the coordinates say 1 and 3,
Yeah.
then you know that it's going to be 1 to the right and 3 up. So you could pretty much just determine right there, like, oh, like if this is a 90-degree angle right here, it's going to be anywhere from the 60 to 90 range. And so you could kind of use that to direct your answer.
Okay.
Because
Go ahead.
I was going to say, like the other one, the arctangent is 6.2 divided by 3 is 64.18. You know that's not right because it's going west in that direction.
Mm-hmm.
And so, and then you know that because the river is going faster north, going up, that the angle is going to be closer going up. So you just do 180 minus 64.18. It's weird reasoning and it's a weird way to look at it, but that's how I look at it, and it definitely helps me get the right answer. Does that make sense, or am I just, is it
No,
all
that
just
makes sense. I was just looking at that same problem because I looked at that view and example, and they do inverse sine, but they also use the vector in their equation. So maybe it like gets the same answer, but it's just a different way of doing it.
Huh.
Because if you, I don't know if you've ever used that, but if you go in that like question, like it back on the page, it says like question help. There's a view and example, and it shows like pretty much the same thing except for different numbers and how to do the problem.
Interesting.
Because it would be like, I don't know.
Let's see. Sorry.
Is the 6.2 the y? Yes. I think. I don't know.
Can you hear me?
Yes. I don't know what happened.
That was weird. Oh well.
Did you get 64.17? Is that what you got?
At 64.18.
Okay. It's okay. So the way that they did it on like the example thing gets you the same answer. So it's probably just
Oh,
a different way of doing it. So it's not a big deal.
but it's not 64.18 because it's going west.
Yeah, but this
Um,
thing, yeah.
yeah. So I ended up with 115.82 degrees.
Yeah. Okay. Okay. So did you do 2 or 3 or did you just
No, I just trusted you to do it.
That's fine. So I always write it down on like paper.
Yeah, it's okay.
Or 2 because it equals r has r equals 10 over 3 sine of I think that's like theta. I don't know if that's like the right word. Minus 7 cosine of theta. I just times the um denominator by both sides, which would give you on the one side would be 3r sine of theta equals 7r cosine of theta
Oh
equals
dear.
10. Here, I can write it.
Okay.
Hold on. I wish there was something easier than word.
Yeah,
She'd
I
be
think that's one of the things.
0.
Sorry.
You think she'd be annoyed if I just put like sine of 0? Or will she be like, that's not a theta?
Um.
How to find that?
Yeah, just go sign of 0. Just because you don't have anything else better to
Yeah.
use.
Um, Do you want me to just type out both or just the one for now?
Type out both. Might as well, right?
Yeah. Okay. I'm almost done with this one.
While you do that, no rush or anything. I'm gonna try and look in number 4 a little bit more.
Okay. I got for one answer that I think it might be would be -2 and -2 comma -2 square root of 3. But
We'll get back to that. Focus on 2 and focus on 2 and 3 for now.
okay. I have one written out. I just have to write now. The second one.
Okay. I'm gonna run to the bathroom real quick.
Okay.
rectangular. Equals -56. For some reason. Rectangular. Interesting. Okay.
Oh, goodness. I wrote down the question wrong, which is good because I did not know how to fix it if it was something else. I was freaking out. I was like, I don't know what to do now. But it's okay. I just messed up, and that's fine. I think I have both of them written down like the way I want them.
Okay.
So then,
Sorry. Hold on. I'm just making progress.
are you figuring out how to make more than one? Do you think?
Yeah. Okay. What do you got for me?
Oh, sorry. Oh no. I pushed the wrong button to do the screen share.
I'm not screen sharing still, am I?
Okay.
There
Can
you
you see the Word document thing?
go. Let me on yours. Yes, I can.
Okay. So I guess this is kind of how I laid it out. So when I watched a bunch of videos to try to figure out how to do this because I wasn't sure at first. But then I guess you have to like get it set up where you can like substitute like different equations in.
Uh-huh.
It's kind of I should have wrote down the equations because I watched his video and he had like the three written down. Which one was like r squared equals x squared plus y squared, and then there was y equals r cosine of theta, and then x equals r sine of theta. So like for the first one, I like times each side by sine of theta minus or 3 sine of theta minus 7 cosine of theta to get the other sine having 3r sine of theta minus 7. So then you can substitute y and x in for these ones to make it the rectangular.
Gotcha.
In the end, it equals 3y minus 7x minus 10 is like the same equation.
Minus.
I can like maybe copy and paste this and send it if that would be easier for you.
No, this makes sense. This makes sense. I'm just double checking everything based off my notes.
Okay.
12.
And then I'm not 100% sure I did the second side of the second one right, but that's as far as I think you could go. Like, no matter what else you did, it would just kind of be pointless. Or I guess you could square each side. Now that I look at it, because like because x squared plus y squared equals r squared, so I substituted that out, and then for the y and the x, I substituted in r cosine of theta and r sine of theta, and I took the r out for the second part because doesn't that just equal 1? Having top and bottom.
I'm not sure.
Because I thought we did something in one where it was like if you have x to the power of 7 over x to the power of 3, it really just equals x to the power of 4 because you like took out the top and bottom to like simplify it. I mean, I could put them back, but you might be able to square because then it would equal r equals 3 and then just 1 cosine theta divided by sine theta because then it would get rid of the squares on both sides. Do you think that makes it even more simplified?
It's a good question. Wait, so sorry, I'm so confused right now.
No, sorry. I'm probably not good at explaining this.
So are you saying you're not supposed to have the RB squared?
No, it is supposed to be squared. Like, because this equation equals r squared.
Gotcha.
But I was just thinking because both sides are squared and 9, the square root of 9 is 3, you could probably make it like go another step. I'm just not sure if the step is necessary. Like if she wants that far done.
No, I think it looks fine. It makes sense to me.
Yeah.
You know what? Actually, go ahead and email those to me, and I'll put that on our group quiz.
Okay. I think that's how you do it. I mean, you can decide if you want to put the R in, but I think you could take the R out. I would take the R out.
Checking my notes that everything kind of makes sense to me there.
Okay. Stop full screen sharing. And then, no. I'm just going to reply to the email that you just sent and paste it all in.
Okay.
Okay, it should have sent to you.
Okay. I'll just wait a second. It might take a while. Let me find you again. There it is. Okay. Bueno. Got it.
Okay, perfect.
Let me just bold these answers real quick. Bolden. Okay. Screen share. Start screen share to everyone. Okay. And present to everyone. So if we graph 4 and 4 pi divided by 3, you can correct me if I'm wrong, and I might be wrong. But I took 4 times pi divided by 3, which equals 12.18, times that by 180, equals 753. Let's subtract 720. And I ended up with 33.98 degrees. And so if I take it out, if I take out the point 4 and 33 degrees, I'd stop about right there, correct?
It's frozen, so it'll get to it in a second.
Sorry, what?
It's frozen.
Oh.
Is that how you do it?
That's the thing, is I'm not.
Because I thought for some reason you looked at the unit circle.
That's what I was gonna say. So if it's about right there.
Because I think then that's like, I think 240 degrees.
So I think you were right about 3, the square root of 3 divided by 2. I think that's another option. But I'm kind of lost.
Yeah, because I thought when I mean, I could be totally wrong, but I looked up like for the coordinates of 4 pi divided by 3, like on the unit circle, and it's negative 1/2 and negative square root of 3 over 2. And then wasn't there something in the homework where you and then you then you timesed it by 4 because you looked up like, because the equation was like x equals r cosine of theta, and then y equals r sine of theta. So like the cosine of theta is negative 1 over 2.
Cosine of theta.
I don't know if that makes any sense.
No, I think we're overthinking this. I think it's as simple as finding different ways of plotting out that point, just different polar coordinates you can give it. So I think 4 is always going to be that x coordinate, but y can be different because it can be negative, it can be a smaller number. I just don't know. I thought I knew behind exactly where 4 pi divided by 3 is on a unit circle.
It's down in the third quadrant.
Third quadrant. Am I still screen sharing?
Yeah, I don't know if you've moved it since. It's got like a tiny little circle and a.
Let's see. Oh, that doesn't make sense to me. Let's see. Let me go to the homework.
Because I remember the homework had like the graphs that had a bunch of circles on them. And so you like went to the 4 pi over 3 where that line is, which is like the the 200 and what was it, 240 degrees, and then you went out like 4 circles.
Yeah, like this.
Hold on, I'm showing something. Yeah.
Okay. Where is okay, here's one. So 11 pi divided by 6 times pi divided by 6 3
is in the 4th quadrant. If you like look at, if you Google a unit circle, it pulls up what it looks like.
Yes.
And then don't they have it going out 5 circles?
Yes.
Which I think the circles might actually just be the x-axis. Now that I'm looking at this more, like they just might be like 1, 1. Which now makes me feel weird. I just thought they were random circles, but now that I look,
so the circle is based on the number, the x coordinate or 5. That's going to be your magnitude.
yeah, I see that now.
So the way I figured out was in the 4th quadrant is I just take 11 times pi equals 34.55, divide it by 6, and I end up with 5.75. Oops, 5.75, and then I times it by 180, and I get a huge number. I get 1,035, and then I just subtract 720, and I end up with about 315 degrees. Right? And so that's why I think it's in the 4th quadrant. But
I think you're saying 4 pi over 3 is in the 4th quadrant?
I know that doesn't make sense. Why can't I think? Let's view an example.
Yeah, because I know it's not. Like I.
Gives a distance. 7 pi divided by 6.
I guess.
So now our problem is we just need to figure out how do you figure out for the crap, what's the question?
So to convert from, now I need it to the other way.
How do you figure out where 4 pi divided by 3 is on the unit circle?
Because defined the.
Oh dear. Sorry.
To find
Okay, go ahead.
To find x, sorry, couldn't think of the word x. You put in cosine of 4 pi divided by 3.
Oh.
It's negative 1/2. And then for y, it's sine of 4 pi over 3, which is the negative square root of 3 over 2.
Gotcha. Okay.
This says to convert from polar to, I don't know how to say that word. X and Y. It's like some weird. I can just screen share and you can see this. Can we both screen share at the same time?
No, let me turn it off. Sorry. Where is it? Sorry.
It's okay. Sometimes it gets lost.
There it is. Stop. There we go. All yours.
Okay, this is what I was looking at. So use cosine for finding x equals x over 13. Yeah, this is how I did it for the 2 coordinates I found, but I don't know how to find 2 additional.
Okay, I got that. I can do that. -1/2. So you're. Sorry, hold on. How do you get there? That's about 240 degrees. So it's on basically on the 240 degree line, right?
Yes.
Okay.
Here's a unit circle that I looked up because it just gives you like the answers for like the first part, so you just have to times them by 4. Because that's like easier than plugging it in and then figuring what the random decimal means.
Divided by 3. So you could do negative pi divided by 3, right? Because you're moving. Wait, no.
No,
You
I know.
could do
that's how it is, but I don't know how to do it that way.
You could do negative 2 pi divided by 3.
But doesn't that still get you the same points? It just gives you different polar points. Is that what she wants?
That's the best guess I could come up with. I don't see why it wouldn't work.
Oh yeah, it says name 2 other polar coordinates.
Yeah.
Oh. That means we were definitely overthinking it.
Yeah.
Oh man. Sorry.
No, you're good. So negative negative 2 pi divided by 3. And then what's another one we could do?
You just times it by 2 pi, so wouldn't that be 8 pi over 3?
Makes sense to me. Do you want to check it real fast?
I'm
Let's
stop this real quick.
Okay.
Because don't you just times it by 2 pi to get a full circle?
Divided by 3, sine. 6, yes. It wasn't negative. And then 8 times pi divided by 3 cosine equals negative 0.5. Yeah, I think that works.
Yeah, so you can just like give her like timesing it by 2 pi. And then, or even like timesing it by 4 pi, because I still think that's like 2 complete circles around.
Zoomed in.
I don't know how to do like finding a negative circle of it.
I did the negative. So I ended up with, where is our thing? There it is.
Would it be?
So I got 4
Pi over
comma negative 2 pi divided by 3 and 4 comma 8 pi divided by 3.
Yeah, that sounds right.
Sounds good.
Yeah. Man, sorry that I made that harder than it was.
No, it's okay. It took me, I was like, man, this is going to be so hard. And then I realized, oh, you just need to give
The polar coordinate.
coordinates. Next.
I think that's all.
Yep. I'm making it right now, and I will turn it in for us.
Oh, sounds good.
It says I need to put on participation points. My partner.
Attended meeting and stayed throughout the whole meeting. Oh, so that's all it is if you attend the meeting and stayed throughout the whole meeting. Left
Full
meeting earlier, did not attend at all. Is that how that works?
I just said we deserve 100% on everything because full participation.
Okay.
PDF, turn it in. Next. Group quiz week 9, right?
Yes.
Okay. Save. Sorry. Don't even need to technically be on the meeting with you while I do this, but
That's okay.
submission, upload, group quiz, week number 9. Submit. There you go.
All right.
Sweet. Well, good meeting, and I will see you next Tuesday. Good luck on the test.
Yeah, good luck. Hopefully it's not terrible. Kind of nervous.
Honestly, I feel a lot more confident about these sections than I
Did about
ever
the-
have with calculus and stuff like that.
Yeah.
So,
Are you taking pre-calc next semester or calc next semester? Do you have
Heck
to?
no. Heck no. I have to do physics, which will be difficult, but thank goodness that I do not have to do calculus.
Yeah.
Do you?
Yeah.
That's for you.
I have
Anyway.
3 math classes next semester. But it's all good.
Well, hopefully you start feeling a little bit better this week, and you can start recovering from your surgery and stuff.
Yeah, it'll be good. It's almost over.
Sounds good. Well, hey, have a good rest of the night.
You too. Bye.
Okay, bye.